In this video, we're going to do an example of factoring a polynomial completely. So, we have the function f of x equals 2x to the fifth plus 9x to the fourth minus 11x cubed minus 83x squared minus 77x plus 60. The main tool we have at our disposal is the rational root theorem. The rational root theorem again tells us where the function might have fractions that are roots. So remember, to use the rational root theorem, we need to take factors of the constant and factors of the leading coefficient and make fractions. Well, there are lots and lots of factors of 60. 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So there are those factors of 60. Possible factors of 2 are 1 and 2. So this gives us our possible list of rational zeros. Remember, again, we take all the factors of 60 and put them over 1, and all the factors of 60 and put them over 2. Here's the list of all the factors of 60 over 1. It's just the same list as the factors of 60. Here's all of the factors of 60 over 2, but we eliminated any of the ones that had an even numerator because when I reduced it, became one of these that were below it. All right, so let's look at a graph. Here's a graph of f of x, and we're going to figure out which of these might help us. Now, it's a little hard to see on this particular graph, but these units along the x-axis are by ones. So it looks like it crosses the x-axis at -4, maybe here at 1/2, and here at 3. So we'll try those first. We'll do successive rounds of synthetic division to see that these are in fact zeros. So first I'll put in -4. Here are the coefficients for the original polynomial. And we do our synthetic division like we always do. Bring down the first one, multiply, add down, multiply, add down, multiply, add down, multiply, add down, and finally multiply and add down, and you get down to 0. So I really do have a 0 at x equal to -4, and we've also reduced the polynomial from a 5th degree polynomial to a 4th degree polynomial. So now I'm going to check to see whether or not the 1/2 is a factor of this new polynomial with a 4th degree instead of a 5th degree. All right, so I put the coefficients for that polynomial here, not the original. I want to use this new one that I've reduced it, because our goal again here is to get down to a quadratic if we can. So then we put in 1/2, and again, same process. Bring down the coefficient, multiply, add, multiply, add, multiply, add, multiply, add. We get to 0. So again, we get 1/2 as a 0. Now we've knocked this down to we started with a 5th degree polynomial. One round of synthetic division got us a 4th degree polynomial. Another round of division gives us a 3rd degree polynomial. Let's do it one more time to get to a quadratic. Here are the coefficients for that 3rd degree polynomial. Here's the thing we think is a root. Bring down the first coefficient, multiply, add, multiply, add, multiply, add. We get 0 again. So we really do have zeros of -4, 1/2, and 3. So finally, we're going to find the zeros of this 2x squared plus 8x plus 10. So we set it equal to 0. It doesn't factor nicely, so we'll use a quadratic formula. I could have also divided both sides by 2 to start with, but that doesn't really matter in the context of the problem. -b, so -8, plus or minus 8 squared minus 4 times 2 times 10, all over 2 times 2. Underneath, the radical simplifies to -16, so you get a -8 plus or minus 4i. Factor out a 4 and cancel, you'll get down to -2 plus or minus I. All right, so since we found the 5 zeros, we now know that we have 5 factors. Remember, if something is a 0, x minus that something is also a factor. So those are the factors that we have. Now notice, though, if we multiply all of these together, we end up with a leading coefficient of 1. The original polynomial had a leading coefficient of 2. So when I multiply these 5 factors together, I also need to put a 2 out in front to make sure that my leading coefficient is correct. So we'll get 2 times the x plus 4 times the x minus a half times the x minus 3 times x minus a negative 2 plus I and the x minus a negative 2 minus I. To clean things up, make it look a little bit nicer, I can take this 2 and multiply it by this factor and change it into a 2x minus 1.